So on number 7, we have another related rate question, and it says it related rate there. But we also know this because, as it's described, the triangle has a height that is increasing at a rate of. So we see that word right there, and its area is increasing at a rate of. Right. So we have these related rates here, and then it says find the rate at which the base of the triangle is changing when the height of the triangle is 10 centimeters and the base is 12 centimeters. Okay. So we know it's a related rate question. We want to look at the shape or identify the shape, which in this case it's a triangle. Okay, and and then we want to think about the variables. So there are a couple different formulas for triangle. So what we're measuring here is area, right? And we're talking about the height and the base, right? So then here it says the height and the base again, right? So we want a formula that gives us area of a triangle in terms of height and base, right? And luckily, if we look on our formula sheet, we have such a formula, and it's going to be area equals 1/2 base times height, okay? And so that's the formula we're going to be using for this situation. If we want to draw a diagram, we have this triangle, right, with height h and base b, and then the area is the space that makes that up, right? Is this space here, okay? And um, so let's first take the derivative of this, and with respect to time, right? So we're going to ddt this, all right? And so then we end up with a prime equals. Now here, um, we have to use the product rule, right? Because we have two different variable expressions multiplied together. And so we can think of one of these as our f and another one as our g. And so we can do f prime g plus g prime f, right? Now, one thing about this is I'm going to take actually the 1/2 and the bh, or excuse me, the 1/2 with the b together as my f function. So the 1/2 is going to be part of the f function. The other way you can do it is you can use constant multiple rule and keep it 1/2 on the outside. But I think this will make it a little easier to solve for and keep everything kind of separate. Another thing you could do is you can multiply everything by 2 to start with, um, and get rid of the 1/2, and that would work too. But I'm just going to keep it this way. So so when I take the derivative of 1/2 b with respect to time, what I'm going to get is I'm going to get 1/2, right? The derivative of 1/2 b is just 1/2, but then I have to tag on a b prime. Okay, so that's like the f prime there, and then I'm going to tag on the g, right, which is h, plus now I'm going to take the derivative of the g part, which is the derivative of h is just 1 times h prime, so it's just going to be h prime, and then I'm going to multiply 1/2 b, right, the original f there. Okay, so again, what we have here is we have f prime, right, times g plus g prime times f. Okay, all right, so now we can start plugging in stuff right here if we wanted to. You can also kind of simplify first if you like. Another way to kind of write that would be just like, 1/2 h b prime, just to put the primes at the end, and then we have 1/2 b h prime. So if you want to do that, you could. But again, you can start plugging in and solving it from that step if you wanted to. Okay, so now they give us a bunch of numbers. So let's kind of figure out where these numerical values go. So the first one is they give us this 3 centimeters per second. So because it's a per and there's a time value there, that's probably going to be a rate, and it does say the word rate. And it's the rate at which the height is increasing, right? Height is increasing at a rate. That's going to be h prime, right? So whenever it's a rate, it's going to be prime, and this happens to be the rate of change of the height. So there's going to be 3. Okay. Then in the next part it says is the area is increasing at a rate of 53 square centimeters per second, centimeters squared per second. So that's another rate. It's another per second. And so that's going to be the rate at which the area changes. So that's going to be A prime. Okay, A prime is going to be 53. So I'm going to put 53 in for A. Okay. Then it asks us the question, find the rate, or it tells us at least find the rate at which the base of the triangle is changing. And so they're asking for B prime, right? The rate at which the base of the triangle is changing is B prime. So that's what they're asking for. Okay, so this one is the one that we're going to be solving for. And then it says when the height is 10, okay, so that 10 is just going to be h, the height, not the rate of change of height, just the height itself, and then the base is 12, right? That 12 is going to be b, okay? So we want to know when the height is 10 and the base is 12, and the area is increasing at a rate of 53 square centimeters per second, and the height is increasing at 3 centimeters per second, what is the rate of change of the base, okay? So we're going to put 10 in for height, and we're going to put 12 in for base. All right, so now we're ready to go. So it's going to be 53 equals 1/2 times 10 times b prime plus 1/2 times 12 times 3. Okay, and then we can just simplify a little bit here. So 1/2 times 10, this value is just going to be 5. So 5b prime, and then plus, and then we multiply all these together. 1/2 times 12 is 6. 6 times 3 is 18. So we get 18. Then we can subtract 18 from both sides. And so we get 53 minus 18 is 35 equals 5b prime. We can divide both sides by 5 here. And so we get b prime equals 7. Okay, so we're good there. We got our value, but don't forget your units. So remember, we're talking about the rate of change of the base. And the height is centimeters per second. The area is square centimeters per second, centimeters squared per second. And so for base, that's going to be centimeters per second. Same as height because it's a length, right? All right, so 7 centimeters per second is the rate of change of our base when all the other parameters are in place. And so that's the answer to this question here. Okay, let me know if you have any questions on it or if you found any mistakes.